Hi everyone. So let's talk about page 190, investigation 13. First of all, I think the issue that several people had was in realizing what x equals 0, x equals 10, y equals 0, and y equals 10 are. So you can look at this for a review on page 167. It's also something which we've gone over many times. So most of you are familiar with, you're all familiar with y equals mx plus b. And if I give you an equation like y equals 5x plus 12, you're like, oh, okay, I know how to deal with that. That looks familiar, and that's going to make a line. All right, well, you can also have y equals 6, y equals negative 7, x equals 8, x equals negative, I'm just making stuff up here, 9. You can also have x equals 0 and y equals 0. So I said before, with problems like this, if you don't know how to graph this, and the easiest way would be to find the x and y intercepts. Second easiest way would be to plot the y-intercept, which would be at 12. Let's call that 12. And then this is a slope of up 5 and over 1. So you go up 5 over 1, up 5 over 1, up, do that, and then go, oh, there's my line. The intercepts would be to, well, there's your y-intercept right there. Your x-intercept is going to be equal to negative 12 over 5. So it'd be over here somewhere. So those are two methods. The third method, which again we've gone over in class, and this always works, is to make a table of values. So if I made a table of values with this one, I have an input, which are x values, and I have an output, which are y values. And my x, I can pick whatever values that I want for x, but it's helpful to pick negative 2, negative 1, 0, 1, 2. And I picked a couple of negatives, a couple of positives, and then 0. All right, so those are my inputs. What are my outputs? Well, if my input is negative 2, what is my output? Well, that's where I go up to y. And I say 5 times negative 2 is negative 10. Negative 10 plus 12 is 2. All right, and then I can go through and I can do the same thing with each one of these. 5 times negative 1 is negative 5. Negative 5 plus 12 is 7. 0 times that, we get 12. This is 5 times 1. Is 5 plus 12 is 17. 5 times 2 is 10 plus 12 is 22. Okay, and then I can come over here and I can plot these. I can just go negative 1, negative 2, 1, 2. There's 1 point. I have another one at negative 1 and 7. And you get the idea. And then I'm going to end up with a bunch of points, and then I just put them together. Okay, so what about things like this or these other ones? Well, they work the same as well. If you don't know how to graph these, then make up a table of values. So let's have x, let's have y, negative 2, negative 1, 0, 1, 2. And if my x input is negative 2, and let's say that y equals 6 is the equation that I'm trying to solve, well, if x equals negative 2, where do I input x into this? Up here, I put x into there. So that was obvious. But what about here? Well, here, this is just a constant. It's telling you y is always 6. So if x is negative 2, y equals 6. If x is equal to negative 1, y equals 6. So no matter what the input is, it's 6. If we input it into x into y equals negative 7, then again, this is negative 7, negative 7, negative 7, negative 7, negative 7. All right, so what does this look like if I want to graph it? Well, if I want to graph it, and then I go over here, and I say x equals negative 2, so negative 2, 6, negative 1, 6, 0, 6, 1, 6, 2, 6. No matter what my x value is, my y value is always 6. So this is y equals 6. And it works similarly so for x equals 8. In this case, you don't have an input of x, you're going to have an input of y. So y is now your input if you want to look at it that way. And then x equals 8. And again, I have negative 2, negative 1, 0, 1, 2. What then does x equal when y equals negative 2? Well, x is always 8, so this is going to be 8, 8, 8, 8. What does that look like? 1, 2, 3, 4, 5, 6, 7, 8. And it's a vertical line, and we call that x is equal to 8. And again, if so x is equal to -9 would be over here, be -9. What about these ones? Well, x equals 0. Here's 8, 7, 6, 5, 4, 3, 2. X equals 2, x equals 1, x equals -1, -2. This is x equals 0, also known as the y-axis. Similarly, so what is y equals 0? Well, there's 6, y equals 5, 4, y equals 3, y equals 2, y equals 1. Y equals 0, also known as the x-axis. Okay, so I think that tripped some people up going into investigation number 13. And investigation number 13, it starts off by saying, on a coordinate system, draw the lines with equations x equals 0, x equals 10, y equals 0, y equals 10 to mark the boundaries of the town. And it says, use technology or a graph paper. Well, let's say that you don't have technology and you do not have a graph paper. All right, let's just use something as simple as this. And if you can draw it as well as me, fantastic. So draw the lines, x is equal to 0. Okay, well, x is equal to 0. Again, this is x equals 5, x equals 4, x equals 3. So here's x equals 0 right there, which is also the y-axis. And I'll just label this x equals 0. Y equals 0. Well, we just learned that this is any horizontal line, y equals is going to be a horizontal line. There we go. And then x is equal to 10. That's up here. X is equal to 10. And then it says y equals 10. Y equals 10 is going to be this. Y equals 10. And so now I have my boundaries of the town. Hospitals A and B. So question number 2. Hospitals A and B have coordinates 1, 8, and 8, 8. 1, 8. And that's, this is hospital A, and hospital B is 8, 8, which is right here, hospital B. And that's question number 2. Locate them on the coordinate system and label them with A and B. Okay, locate the midpoint of A, B, and label it M1. Well, midpoint formula then is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we know this one is 1, 8. We know this is 8, 8. So this is just x1, y1, x2, y2. And it doesn't, I could have said this one's x1, x2, and that one's y1. It doesn't matter. So we got 1 plus 8 divided by 2, and 8 plus 8 divided by 2. And so that's 9 over 2 and 16 over 2. Which you can leave that as 9 over 2, or you can call it 4.5 over comma 8. So then this midpoint right here, this midpoint is going to be at 4.5. So there's right about there. And then we're supposed to label this M1. There we go. Okay, locate the midpoint. We did that. Draw the perpendicular bisector of AB. Okay, so the perpendicular bisector of AB is simply going to be a line that comes through here at a right angle. So this is 90 degrees. There we go. Hospital C has coordinates 3, 2, 3, 2. There we go. This is C. Let's label this 3, 2. And it says locate the midpoint of AC. So I got to find the midpoint here of AC. Well, the midpoint of AC is just going to be this again. So it's going to be x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. And in this case, that's x1, y1. So this is going to be 1 plus 3 divided by 2. And this is 8 plus 2 divided by 2. So that gives me 2. And 10 divided by 2 is 5. So that's 2, 5. Okay, and then I label that. So this is 2 and 5, and that actually looks like it's pretty decent. Okay, and then it's going to be at a right angle. So it's approximately like, I don't know, like right angle, something like that. Okay, there we go. And then the next question. So this is now a question. I was supposed to label that M2. There we go, M2. Question 5 says locate the midpoint of BC. So the midpoint of BC. So we're going to go through this process again. So it's going to be 3 plus 8 divided by 2 and 8 plus 2 divided by 2. So that's 11 over 2 and 10 over 2 is 5. Let's call this 6.5. No, sorry, 5.5. So this is 5.5, comma 5. So 5.5 is about there, and then up to 5, which is about there. So that's going to be the midpoint. Maybe I'm just a little bit off there with my line. There, I'll just make the dot bigger. Okay, and now I'm going to draw at a right angle to this. I'm going to draw a perpendicular bisector here. And I think that looks pretty good to be a right angle. Okay, locate the midpoint of BC. So we did that, and then we call this M3. Okay, and then question 6 asks, with the perpendicular bisector of AB, this perpendicular bisector here, intersect the perpendicular bisector of AC. Well, here's AC, here's perpendicular bisector. Do they intersect? Yes, they do. Same with, does perpendicular of AB intersect BC? So again, perpendicular of AB is this, and of BC is this. And so yes, they also intersect. And then does the perpendicular bisector of AC intersect the perpendicular of BC? Yes, they do. Why do they? Well, unless the lines are parallel, they are going to intersect. So that's it. That's the end of it. Would all 3 perpendicular bisectors intersect in one point or not? Yeah, in fact, we can see it right here. That is the intersection point. There's one bisect. That's a bisector of AB. This is a bisector of BC. This is a bisector of AC. So right there. Okay. Question number 7. Where would the boundaries or the Voronoi diagram be? Okay, so the Voronoi diagram in the first place, the reason for it is that it gives us, in this case, we're looking at 3 hospitals, A, B, C. And if a person lives in any particular section of this, wherever they live within this town, they should be going to either hospital A, hospital B, hospital C, depending upon where they live. But how do we know that? Well, what we're looking at then, the Voronoi diagram helps us answer that question. And we have some boundaries that are created by the intersections of these perpendicular bisectors. There we go. So this says, all right, if you live in this section, you should be going to hospital A. In this section, you should be going to hospital B. And in this section, you should be going to hospital C. This point here is equidistant from A, B, and C. And I think they have us, at some point, I think we label this S. Okay, so that actually answers questions 7 and 8. We don't have a pentagon tool because we're not using a piece technology, but you would just shade it like this, shade it like that, and then some combination for that one. And on the set of solutions, which is actually posted, I do a little bit better job on question number 9 of shading. But anyhow, which point is equally distant? We already answered that one. It's right there. Samara's house is located at 0.45. Where's 0.45? There's 4, and here is 5 right there. So yeah, he should be going, he should be going to C, hospital. What does Voronoi diagram show? We already talked about that one. It says which hospital it should be going where, so that we can, and it works for hospitals or lots of other things too. Where should a garbage dump be located? If this is a town, this is a town, this is a town, where is one possibility? Well, maybe there, and it's, it comprises an area in all 3 sectors. Why is a vertex always equidistant from these sites? So this is where the perpendicular bisectors overlap. And then how many edges are at a vertex? We have 1 edge, 2 edge, 3 edges. There we go. And there's more detailed solutions, and I wrote some things out in the posted solutions. I hope this has been helpful. If it has or has not, you have further questions, just please let me know. That's what I'm here for.